Slope and writing linear equations. On your note sheet, they talk about that the grade of a road is a percent that measures the steepness of the road. It's found by dividing the amount the road rises by the corresponding horizontal distance. You have talked about this grade before, probably heard it as a different name. When you take the rise over the horizontal distance, oftentimes we also call that the run, that is a measure of slope. So slope or grade of the road deals with your vertical distance over your horizontal distance or rise over run. So slope of a line is the ratio of the change in its y. Remember, y is up and down to the change in its x. And remember, x is vertical. So it's change in y over change in x. And we often write that is slope using m, and it can be your change in y over your change in x. And if you're using coordinates, we would write that as y2 minus y1 over x2 minus x1. Some slopes you should know. A line that rises to the right is said to have a positive slope. So this is going to have some kind of positive number associated with the slope for that one. Any horizontal line has a slope of 0. So anytime your line goes straight across, you get slope of 0. And this can be found if you take these 2 points here and subtract them using the slope formula we just talked about. You can see it happens. 2 minus 2 would be the 2y coordinates. 3 minus negative 3 would be the x coordinates, and when you subtract those, you get 0 over 6, which is equal to 0. So this one does have a slope of 0. When the line falls to the right, the slope is negative. So there's some negative slope associated with any line falling from left to right. Finally, if the line is vertical up and down, then we call the slope undefined. And again, you can see this by checking. If we find the slope of this vertical line, you would get negative 2 minus 3 on top when you subtract the y's, negative 2 minus negative 2 on bottom when you subtract the x's. That gives us negative 5 over 0. Well, dividing by 0 is not allowed. If you try it on your calculator, you can see when you take any number like negative 5 and divide by 0, your calculator gives you an error because you cannot divide by 0. That's why we say the slope would be undefined. Now, some people have a hard time remembering like what type of line has slope of 0, what type of line has undefined. Slope is always something you can like walk on. You can walk up positive slope. You can walk down negative slope. You can walk on slopes of 0, but you can't walk on the undefined slope. Unless you're like Spider-Man, you can't walk up a wall. So undefined is that one you can't walk on. A few other things you should know about slope here, and that is a slope of 2 different types of lines. Anytime you have 2 lines that have the same slope, we know that those are parallel lines. Parallel lines have the same slope. Lines that have slopes that are opposite reciprocals of each other we call perpendicular. Perpendicular lines have slopes that are opposite reciprocals. So let's get an example of that. Let's say we had a slope on this line right here of up to over 3. The slope then of this other line that's slanting down, we know would have to be negative. We talked about before, any line slanting from left to right downward is negative, and it would be reciprocal. Remember, reciprocal means you flip the fraction, so the slope of this other line would be negative 3 over 2. So it's opposite reciprocals. All right, let's try some examples from your sheet. The first problem says find the slope of a line that passes through these 2 points. All right, well, let's try it. Using the slope formula we talked about before, you want to take and subtract y2 minus y1 over x2 minus x1. Now, if you can't remember which one's which, you can always label the points. Like we know every ordered pair has a xy, xy. We could call this point 1, this 0.2. Now you just got to plug the numbers in to see what you get. So we'd have -2 minus 4 over 1 minus -1. On top, if you subtract those, you get value of -6. On bottom, anytime you're subtracting negative, that's also the same as adding. So we get 2. So simplifying that fraction, we get -3 over 1, or we can just write that as -3. So the slope would be -3. For tomorrow, why don't you try out B and see what you get for the slope there, and we'll check that one tomorrow. All right. The next problems on your note sheet, they want us to graph some lines with some given conditions here. So let's try out and see what we get. On this first one, on A, they want us to graph a line that has a slope of 1/2 and passes through the point 2, 1. Whenever you're doing this, you can't start with a slope unless you know where to start. So the point comes first. And remember, it's always x, y with your points. So we want to go 2 to the right, and -1 telling us to go down 1. There's our point to -1. Now we can move over and do our slope. A slope of 1 over 2 means we're going up 1, right 2. So we start at the point we graphed, we go up 1, right 2, up 1, right 2, and we can keep doing that pattern, or we could go the opposite way, down 1, left 2, down 1, left 2. Get enough points that you know what the lines are going to look like, connect them, and there's your line. All right. For tomorrow, why don't you try out B and see if you can graph that one. We'll take a look at that problem tomorrow. All right, another term that you should know is rate of change. Rate of change is just a fancy way of saying slope. Slope and rate of change are the same things. And what rate of change is the measure of how much a quantity changes on average relative to another quantity oftentimes. So when you're comparing and finding the difference of two quantities and dividing them or doing a ratio, that is the same thing as finding slope. All right, so this example on the back of your note sheet talks about using this table of time and temperature to find some rates of change. For A, they want to know what's the average rate of change. All right, that's what we just talked about. Remember, this is the same as finding slope. So basically, they want us to find a slope of the temperature from 8 a.m. to 10 a.m. All right, so what we need to do here is figure out what was the change in temperature in that time. So from 8 to 10, it looks like we changed from 36 to 47. Now, when you're doing that, if we subtract 47 degrees minus 36 degrees, that's going to leave us with 11 degrees. Now, that's how much it changed, but that's not the average rate of change. They want to know per hour, how many degrees were we changing on average. To figure that out, we need to divide this by the difference in time. The time associated with 47 degrees was 10 a.m. The time associated with 36 degrees was 8 a.m. If we subtract those, it changed 11 degrees over 2 hours, meaning the average rate of change or slope was 5.5 degrees Fahrenheit per hour. So that would be our average rate of change or slope during that time period. All right. For tomorrow, I want you guys to try B. See if you can find the average rate of change from 12 to 4. So try that one out for tomorrow. Let's see if we can answer C together, though. C wants to know during what 2-hour period was the average rate of change the least? Well, looking at our chart up here, it appears that all our time is 2-hour increments here. From there to there is 2 hour, 2 hours, 2 hours, 2 hours. So if we wanted to find what is the least amount of average rate of change, look for the least amount of change in temperature between any of these. Here it looks like our change is 11. Here it looks like our change is 8. Here it looks like our change is 3. Here our change is 2. So which one had the least amount of average rate of change? It's going to be that 2 p.m. to 4 p.m. time frame. All right. Problem 4, this is the one dealing with money. It says Kevin's savings account balance changed from 1,140 degrees in January to 1,450 in April. Find the average rate of change per month. Okay, again, average rate of change, what's the slope? So you got to subtract some things on top, subtract some things on bottom, and find out on average how much is it changing. So we need to take the money here and see what's the change in money. But don't forget, you need to, on bottom, find out how much time did it change over. April to January, we got January, February, March, April, that's over 4 months. So if we subtract on top, we get it changed $310 over 4 months, leaving us an average rate of change or slope of $77.50 per month, per 1 month. So that would be our average rate of change. All right, moving on here. Slope-intercept form. This is something you looked at last year. You should know anytime you have a line in slope-intercept form, M is your slope, B is your y-intercept. So you can graph a line by knowing first what's the y-intercept and then use the slope to graph after that. Some other things though you might run into is what happens if you are given a slope and a point? What can you do then to get the equation? Well, if that happens, what you're going to do is plug the slope and a point, x1, y1, into another equation called the point slope form. And point slope form is this equation right here. Often used as nearly as much as slope-intercept form that we just talked about. So point slope form, y minus y1 equals m, m's the slope again, times the quantity x minus x1. So if you have a slope and a point, you use point slope form. We'll look at an example of that in a second. If you're given 2 points and you want to find the equation, first find the slope, just like we've already did on this note sheet, and then plug the slope and one of your 2 points into point slope form and rewrite your equation into slope-intercept form. Let's try that one out here. Let's look at example 5. Write an equation in slope-intercept form for a line that has a slope. Okay, so they're giving us a slope and passes through the point negative 4, 1. This is a problem where you got slope and a point. We're going to use point slope form in order to do it. Point slope form looks like this, where we have to plug in some numbers here and figure out what the equation is going to be. So in for these 3 things, we need to plug in a slope and a point. Our slope that we're going to plug in is already given to us. It's negative 3/2. That goes in for m. Our point is negative 4, 1. Now remember with the point, it's always x first, y second. So we want to plug in our x1 and y1 into here. So x1 is negative 4 and y1 is 1. Now if we simplify this equation, it'll give us our line in slope-intercept form. First thing you probably want to do, anytime it's a minus and negative, we know that that's going to change into x plus 4. And I would change that just so you're not going to screw up any of your signs as you're simplifying. All right, next, looks like we need to do some distributing, so let's distribute negative 3/2. Negative 3/2 times x is that. Negative 3/2 times 4 is going to give us negative 6. Finally, add 1 to both sides, and we'll have our equation. And our equation for this one would turn out to be y equals negative 3/2 x minus 5. We'll try some more of those in class tomorrow.